before the time of smartphones and GPS, you actually had to use maps. I know you've seen them in pirate movies where they're always using them to find the buried treasure, but on the map in the corner, we use these all the time. They represented something in real life to a much smaller scale. And our scale, just like this here, tells us the real distance based on a proportional relationship on the map. So what I mean is, on our scale here, the map is 1/8 of an inch. I'm going to write it over here. Every time I measure 1/8 of an inch, it is equal to 12 miles in real life. So this is my map. And this is, I'm going to call it reality, what's actually there in real life. So if I'm looking at this line and it represents the distance between two cities, and I will say this is not drawn to scale, so if you try to measure it on the screen, depending on the screen, you're not going to measure it correctly. This represents 1 1/8 inches. So what we want to know is, what is that in real life? Because clearly these two towns are not that close together. So we're going to use that relationship between these two numbers to find the real distance. Watch what I'm going to do using math. And I'm going to use that key, that scale, as my first ratio. And I'm going to use the inches, and I'm going to use miles. So in other words, this is what's on the map, and this is what's the actual thing that's happening in real life, the actual distance. So I know that 1/8 inches is the same as 12 miles, and I want to know how far 1 1/8 inches is in real life. So I'm going to set that up because that's the relationship that will help me find a bigger ratio, the larger one. We're going to do our usual cross multiplying, and I'm going to give us some room so we can write this out. As you can see, crossing on my left, I have 1/8 times a number is equal to 1 1/8 times 12. Let's make this into something more workable. So 9/8, I just changed it to an improper fraction, times 12 over 1. And we can actually solve that out. We know this is 108 over 8. I'm not going to change it to a mixed number right now because you can see I'm going to have to do another step with our fraction. I'm going to have to divide by 1/8 and 1/8. So I'm going to again give myself some more room. Now I have n is equal to 108 over 8, and I'm going to divide it by 1/8. So let's rewrite this. Okay, we know it's a division problem. So we're going to divide by 1/8, or we're going to just multiply by the reciprocal. We know this. I'm going to leave both of them there so you can see where those numbers are coming from. Part of me wanted to just multiply by the reciprocal, but I know sometimes we get lost. Like, where did she get that number from? Here it is, so you can see my thinking. I'm making it super visible. I'm just rewriting it as a multiplication sentence. And I'm getting, and I can do something here I'm going to show you in a second. I'm getting 864 divided by 8. And when I simplify that, 864, if you need to, you can get out your calculator, but we kind of just did this math, right? We did 108 times 8. So now we're just going to do that answer divided by 8. I'm going to end up getting 108 again. And I'm just going to put this into context just so you can see. When you have a multiplication sentence like this, and you have the same factor in the numerator and the denominator, in a sense, they're going to cancel back to a 1 because I'm multiplying by 8 and then dividing by 8. So essentially, they null and void each other. Look at what happened here. I multiplied by 8 and then I had to divide back at 8. I ended up back with 108. So when you see that, a lot of times you'll see this in the slash work, and that just means that they just become 1 and 1. So I will still get 108 over 1. I just want to show you that part because sometimes you'll see that in work. So let's put our answer into context. N is equal to 108. What does that mean? I'm going to put it as a full sentence, the actual distance between Lee Springs and Boothville is 108 miles. So I'm going to just box my final answer. You can follow through my work, and here you go, Math Marbles. Notice I just want to make sure I have all my units, but the key to this one, the key to when we're doing scale factor is using that scale as our first ratio relationship. That's going to be the criteria, the key to be successful in the practice problems for today. Hit pause and jot this down in your notes before we do one more model. Here's our second model problem. Jack is using a plan shown below to build a deck. So you can see it's rectangular. We have the length and width in inches, and you see the key at the bottom, which is the same as our scale, where 1/4 inch is equal to 1 5/10 feet. Based on Jack's plans, what will be the actual length of the deck? So they're asking us just that question, what is the length of the actual deck? And we know the scale is 1/4 is equal to 1 5/10 feet. We know the length of the model on the plans, and we know the width on the plans. Our goal is to use math throughout the problem to work this out. Now, I will say we're only looking at the length, so I don't even need the fact about the width. And I'm also going to convert that fraction to a decimal so that when I'm doing my multiplication and division, they're all the same, and it's easier with a decimal and working it out with a calculator than it would be with a fraction and a decimal. And I'm going to use as my very first ratio that scale from the key. That 1/4, which I'm turning again into a decimal, 25 hundredths, is to 1 5/10 feet. So that's going to be my first ratio in the first box. And then I'm going to, in the second box, figure out when I have 3 25 hundredths inches, how many feet is that? And again, I'm using that one because that is the length. I don't want to use 2 5/10 because that is the width. So take a moment, jot this one down in your notes, and we'll go right into our model. Let's put this into action now. And I'm going to start with our units. We have from our key, inches and feet. And I'm going to start with that scale, the scale and the key. And I'm just putting in the numbers. Notice I did change it to a decimal to make it easier. And I'm trying to find the length. So I have 3 25 hundredths. I'm not using the 2 5/10 because that is a width. And I want this number here. So let's cross multiply. And we have 25 hundredths times the number is equal to 3 25 hundredths times 1 5/10. We're going to simplify this one on the right. And this is just using my calculator. This is the number you would get for an 875 thousandths. Now we're going to simplify by 25 hundredths on both ends. And that means n is equal to 19 5/10. Let's put it into context. 19 5/10 feet. So here's my answer. The actual length of the deck is 19 5/10 feet, period. Hit pause so you can jot this into your notes.